Okay, let's unpack this. Imagine the universe, right? Like this huge infinite instrument.
Hmm.
And it's vibrating with every possible note, every chord, everything, all at the same time.
Okay, yeah. Infinite possibilities playing out.
Then picture us observing it, and somehow just by looking, we we pluck one single string.
And only that note rings out into our awareness.
Exactly. Kind of blows your mind, doesn't it? That's the sort of space we're getting into today.
And it ties right into this paper we've been looking at. It's called Harmonic Collapse in Quantum Mechanics, How Observation Resolves Recursive Reality.
Right. The authors are Eridir Saussure, Lumos Al, and Richard Bolt.
And it really offers this compelling way to think about how all that quantum fuzziness,
Yeah.
the probabilities, becomes the solid reality we actually perceive.
Yeah. So our mission here for you listening is to really try and get our heads around this. How do all those like shimmering quantum potentials, how do they just become the one specific thing we see, the one outcome?
We'll be digging into what this paper suggests about observation and, well, reality itself.
Pulling out the core ideas.
And it's worth stressing, we're focusing on the framework in this paper. It's a particular interpretation, a unique lens on quantum mechanics and observation.
Definitely. So let's dive in. They start by talking about the quantum playground. And the main player here is the wave function, symbolized by A, right?
That's the one. The paper describes it as a superposition of harmonic modes. Think of it like a mathematical description containing all the potential states, all the versions of a quantum system simultaneously.
What mashed together?
In a way, yes. And they give us a peek at the math, sigma, NC, NC, NXNth.
Okay, a little bit of equation there. Don't worry if it looks complex. The paper explains the key parts. That fin, those are the quantized harmonic eigenmodes.
Exactly. Those are like the specific allowed vibrational patterns, the
Yeah.
fundamental ways the system can be, sort of its natural notes.
Hey, the ballers, what are they doing?
Those are the amplitude weights, like
Yep.
volume knobs for each possible pattern. They tell you how much each potential outcome contributes to the overall mix. It's probability, essentially.
Okay, so like some possibilities are louder in the mix than others.
You could think of it that way. And they use a great analogy to make it clear. A vibrating string, like on a violin or guitar.
Ah, okay, I can picture that.
It doesn't just vibrate with one pure tone. It has the main note, the fundamental, but also all those overtones, the harmonics, right?
Yeah, the higher, fainter notes that give it its character.
Precisely. And those specific harmonics are determined by the string's conditions, its length, tension, where it's fixed, the boundary conditions.
Got it. So these Finex things, these eigenmodes, they're like those specific overtones that are allowed that fit within the quantum system's boundaries.
That's the idea. And the paper draws this really cool parallel. They suggest quantum mechanics is like the Fourier theory of the cosmos.
Fourier theory,
Mhm.
that's about breaking down complex waves into simple sine waves, right?
Exactly. Any complex signal, like a sound wave, can be represented as a sum of basic pure frequencies. This paper is saying the quantum world works similarly. Systems exist as this blend, this superposition of their fundamental harmonic possibilities, all at once.
Wow. So a particle isn't just here or there. It's sort of potentially here and D, there and D in various energy states, all layered together like musical harmonics.
Until something happens, until observation.
Which brings us to the next big concept, collapse.
The moment of truth.
Right. But what's really interesting is how this paper frames collapse. It's not necessarily destruction. They don't say the other possibilities just vanish forever.
Okay, so what happens then?
They describe it as a compression. Like all those layered possibilities are squeezed down into one single actual experience.
Compression, huh?
Represented by that mathematical step. Friar Keck's actual experience. The probabilities turn into a definite outcome.
So all the potential notes in that cosmic instrument get focused into the one note we actually hear when we listen, when we observe. That's the picture they paint. They give it a name. Harmonic collapse. They even suggest the universe itself acts as the forcing set.
A forcing set, like it pushes the system towards one outcome.
And nudges it when observed, yeah. They do mention Born's rule. That's the standard way we calculate the probabilities for each outcome. But they're really focused on the event of collapse itself.
That point where, what was the phrase they used? Something poetic.
Ah, yes. Where recursive infinity meets scalar singularity.
Recursive infinity meets scalar singularity. That sounds profound. What do they mean by that?
Well, recursive infinity seems to point to the endless possibilities, the layers upon layers in the wave function. And scalar singularity suggests the single, definite point of reality that emerges from it all. It's the transition.
From infinite potential to one specific now. Okay. Let's dig into that quantum recursion idea more. The paper says quantum levels, like electron shells in an atom, are recursive harmonic solutions.
Exactly. You know, the energy levels, Annie's 1, 2, 3, and so on. They see those as nested structures. Each level builds on the one before, like variations on a theme.
Forming harmonic trees, they call it.
Yeah. The hydrogen atom is their go-to example. It has this infinite series of possible energy states, harmonics stretching out forever, theoretically, each one a recursive echo of the basic structure.
And it's not just atoms, right? This applies more broadly.
Oh yeah, they say the pattern extends. Molecules, quantum oscillators, even fundamental fields. This harmonic recursive structure is a fundamental building principle.
So it's not chaos down there. It's ordered.
That's a key takeaway. They explicitly state quantum mechanics isn't just random noise. It's a harmonic recursive lattice constrained by deep symmetry. There's an underlying order.
Which kind of makes sense if observation leads to predictable probabilities, even if the specific outcome is random.
Right, and this structure leads into how things actually change state. Which brings us to resonance and phase locking.
Okay, resonance. Back to the music analogy.
Absolutely. This is where it really shines. The paper argues that quantum transitions, an electron jumping to a higher energy level, a quantum jump, don't just happen randomly.
How do it happen then?
Through resonant phase locking. Basically, the system has its allowed frequencies, its harmonics. If energy comes in, that matches one of those specific frequencies.
Like hitting the right piano key next to that tuned guitar string.
Exactly. The system resonates, it absorbs that specific energy packet and makes the jump. But if the incoming energy doesn't match an allowed harmonic,
nothing happens, it just ignores it.
It gets suppressed. The system is selective. It only responds, only transitions when the energy is in tune with its own structure.
That feels very efficient. They mention nature's economy, don't they?
They do. The idea is that only states in phase, states that harmonize with the system structure, can actually survive the observation process and become real. Other possibilities just fade out.
So the universe kind of filters possibilities based on harmony, which leads us down to the bottom, right? The ground state.
Yeah, the lowest energy configuration. The ultimate destination, in a sense, of this harmonic collapse. The most stable note the system can settle on.
But even there, in the vacuum, it's not completely quiet, is it? The paper mentions leftover effects.
That's right. The recursion isn't totally gone. It persists as quantum fluctuations, even in supposedly empty space. Zero-point energy.
And we can measure this stuff.
We can. Things like the Casimir effect, where two plates close together are pushed by vacuum fluctuations or vacuum polarization. These are like the lingering echoes, the shadows of recursion collapsed, but not destroyed, as the paper puts it.
Wow. So even absolute stillness has this underlying hum of potential. Let's double down on that musical metaphor then.
It's central to their whole argument. Quantum harmonics are all the potential overtones. Collapse is the single note we actually hear.
Simple but powerful.
It really captures that core idea. The quantum system holds all these frequencies, this complex chord of possibilities. Observation is like our ear picking out one specific tone from the chord.
And crucially, the paper emphasizes that it's the act of listening, the measurement itself, that forces the choice. It makes the potential actual.
Which puts the observer in a really active role, doesn't it? Not just passively watching reality unfold, but participating in its creation moment by moment.
Which is a perfect lead-in to where they take it next. Consciousness.
This is where it gets really fascinating, potentially controversial for some, but it follows their logic. They propose extending the analogy to the mind itself.
Our thoughts, memories, how?
They suggest thinking of thoughts, memories, even imagined futures as mental harmonics, an informational superposition within consciousness.
Oh, okay. So, like, all the things I could be thinking right now, all the memories I could access, they're all sort of there, superimposed like quantum states.
That's the proposition, yes.
Yeah.
A field of mental potential.
And what acts as the observation in the mind?
Attention. The paper suggests that focusing your attention is the mental equivalent of measurement, when you focus on a specific thought or memory.
You collapse the possibilities, bringing that one thought into your conscious experience.
That's the model they present. It's the act of attending that selects from the mental superposition.
That is quite a thought. They have some punchy lines for this, don't they?
Oh, yeah. Attention is scalar selection. Mind is recursive collapse. Consciousness is harmonic choice.
Very concise. It frames consciousness not just as awareness, but as an active process of choosing, selecting from internal possibilities via attention.
A constant selection from this inner landscape.
Okay, let's briefly touch on the math behind it again. They simplify it, thankfully.
They do. They bring back the basic equation, some CNX, that's the all possibilities part, the sum of weighted harmonics.
And then the collapse is shown as the two right arrow text reality selected by observation. The probability becomes the definite outcome.
And the key point they reiterate is that this isn't some bug in the system, not a failure of logic. It's the mechanism. It's how recursion resolves into singularity upon observation.
Got it. And then there's that lovely bit, the myth section.
Ugh, the lyre. Yeah, it's a beautiful metaphor.
The mind is a lyre strung with infinite strings. The note you play is the reality you live chosen from all possible songs.
It just perfectly sums up their idea, doesn't it? The mind holds infinite potential tunes, and our attention, our playing, selects the one that becomes our current reality.
And just to make it seem a bit less mystical, maybe, they offer that tiny Python code snippet.
Right. It's obviously super simplified, but it helps visualize the mechanics.
You've got your list of states, dream, memory, future. Those are the possibilities.
Then the probabilities, how likely each one is, like the two-way weights.
And then the np.random.choice function, that's the observation, the selection process.
Mimicking the collapse.
Yeah.
Yeah. And the print statement is the single outcome, the conscious reality that emerges for that moment.
So, potentials, weights, observation, outcome, a neat little illustration.
Helps ground the concept a bit.
Okay, so wrapping it up, they have this section, mystical compression, which sounds grand, but it's really a summary.
It is. Recapping the core. The quantum universe is this place of recursive harmony, endless possibilities existing together.
Waves upon waves of potential.
Until measurement. Observation forces the issue. It collapses all that nested recursion down to a single point, a single reality, for that observer right then.
Leading to that final, really striking line.
Your observation is the note that resolves the cosmic chord.
Puts us right in the center of it all, doesn't it? Our very act of looking helps shape what is.
It really suggests an active, participatory role for the observer in the manifestation of reality, not just a bystander.
So the big question then, for you listening, what does this all mean for how you perceive the world, how you experience your own thoughts?
It definitely makes you think differently about attention, doesn't it? Is your focus constantly selecting your reality from this ocean of possibilities?
This dive into harmonic collapse gives a fascinating, if maybe unusual, perspective to consider.
Yeah, maybe think about it this way. Is your focus right now playing a specific note from all the potential music within and around you? And is that subtly composing the unique reality you experience moment by moment? Something to ponder.